Chapter 16 in the 6th edition is alternating current. Hopefully it's the same chapter number in the 7th edition of the textbook. If not, I really hope that you did find the correct unit. And again, I apologize for the textbook edition mix-up. It's caused quite a mess, not only in our class. Anyway, the homework for alternating current. Number 1, what is the most common type of AC waveform? It's the sine wave, and we see one here. It's just this very common shape sine wave that just undulates back and forth through 0 up to positive, 0 up to positive, back through 0 to negative, back through 0, and it just continues on forever. Number 2, how many degrees are there in one complete sine wave? It's 360, and we see the values on this picture here. So on the x-axis here, this is the x-axis. It's measured in time. We can see we got 0 here, 90, 180, 270, and 360. So 0 is 0 volts, 90 degrees is the positive peak, 180 degrees is back at 0, 270 degrees is the negative peak, positive up here, and then again 360 goes back through 0, and again this sine wave just continues on forever. Number 3, at what angle does the voltage reach its maximum negative value on a sine wave? We just saw that on the previous question here. It's right here. This is at 270 degrees. You have negative and positive. So it reaches its negative maximum peak at 270 degrees. Frequency. What is frequency? Number 4. So this is one complete cycle, and we can see those cycles just continue, and we saw that the x-axis is measured in time, so as we go along this way, we're further and further along in time. And the question asks, what is frequency? Frequency, here's the answer here. It's the number of these cycles, sorry for the bad drawing, that occur in 1 second. So if, for example, if this is time 0 and this is time 1 second, let's say, we have 1, 2, 3, 4, 5, 6, 7. So it would be 7 hertz in this case, in this quick example. Sorry, before I continue, the unit of measurement for frequency is hertz, and it is defined as the number of complete cycles that occur in 1 second. Okay, now we can continue on to, we're jumping to number 8. Number 8 reads, a sine wave has a peak value. We need to be careful when we read these questions here. Peak value of 433 volts. What is the RMS value? So the peak value is this value here. So this is V peak. This is also V peak. It happens to be negative down here, positive up here, and negative down here. So in the 6th edition on page 400, we get this formula right here. RMS value equals peak value multiplied by 0.707, and that yields an answer of 306 volts. Okay, number 9, a sine wave has a peak-to-peak value. Again, we need to be careful on really looking at what values are in the question. And the question is, what is the average value? So, again, in the 6th edition, it's on page 403, we get this formula right here. Average value equals peak value times 0.637. Now that's, again, average equals peak times 0.637. We're not given peak value. We're given peak to peak value. So we need to do a little bit of math and figure out what the peak value is. So here we have a sine wave, and from here to here, this is V peak to peak. The formula requires the peak value. So to get the peak value from the peak to peak value, we simply divide the peak to peak divided by 2. That's this formula here. So the peak value in this question is 44 volts. It's half of the peak to peak value. Now we can plug in our formula that we have right here. V average equals V peak times 0.637, and we get 28 volts. Number 10, a DC voltage has an average value of 68 volts. What is the RMS value? Again, we're being careful on looking at the values that were given and what are they asking for in the question. In the 6th edition, the formula is given on page 403, and here's the formula that they give on that page. V average equals V RMS times 0.9. Now the question is asking for the RMS value. This formula is solving for the average value. So we need to do a little bit of algebra. I'll do that off to the side. I'm just going to use VA for average equals V RMS times 0.9. We need to solve for RMS. So with an equation like this, if we do something to one side of the equation, we have to do the same thing on the other side of the equation. What I mean by that is V average equals V RMS times 0.9. The left side equals the right side. So if we take, I'm going to reuse these lines here. If we take the right side and divide by 0.9, if we do the same exact thing on the left side of the equation, it's still an equation. The left side still equals the right side. And what that gives is 0.9 divided by 0.9, those cancel out. So I'm going to rewrite this whole equation here, and I'm going to put RMS on the left. V RMS equals V average divided by 0.9. So that's this formula here. Plug in our values that we were given, 68 volts as an average. What is the RMS? It is 75.6 volts. Number 11, an AC waveform has a frequency of 50 Hertz. Be careful here. We here in the US are accustomed to seeing 60 Hertz all the time, so just be careful on the values in the questions. Question, how much time, they're asking for time, is required to complete one cycle? In the 6th edition, it's on, the formula is given on page 395. It's time equals 1 divided by F. Sorry, I'm kind of screwing this up here. The T is for time, and the F is for frequency. And if we plug in the numbers, frequency or time equals 1 divided by the frequency, 1 divided by 50 is 0.02 seconds. This is our answer, or you can change it to the metric equivalent, and that's 20 milliseconds. I will cover these metric prefixes on a different video. And finally, number 12, an AC waveform completes one cycle in 0.8 milliseconds. If you notice it, there's a milliseconds here, and it's asking for the frequency. In the 6th edition, it's on, the formula is on page 395. Frequency equals 1 over time. So I converted the 0.8 milliseconds to seconds. That's this part right here. So that's why we see the 0.0008 seconds. And the final answer is 1250 Hertz.